let's take a look at integrating this function. This is a good review about how to integrate again. If you recall, your exponent increases by 1 and your coefficient is divided by that new exponent. So I would take 3 divided by 5. I'm going to continue that. My next one would be x to the 4th. If I take my negative 3/5 divided by 4, I would have negative 3 over 20. My next term, I have a fraction, so in order to increase it by 1, I'm going to add 5 over 5. My new exponent would be 9/5. If I take the coefficient in front of this term, which is 1, divided by 9/5, that's the same thing as multiplying by its reciprocal, so I would have 5/9. Now, my fourth term, if I continue this process, if I increase it by 1, I would have x to the 0. When I take my coefficient and divide it by 0, now I have an undefined term. However, in math, this isn't undefined. There are special cases and rules with integrals. So here's a list of our rules for integrals. I do want to emphasize, since this is a little tough to see some of the notation, in my second example, that's e raised to the kx power. K is just a numerical value. And on the right-hand side, that would be e raised to the kx again, divided by k, if you can't read that. And then in each of these other ones with sine and cosine, there's also a letter k in front of my x. K is just a numerical value, so keep that in mind. Now, in my last example, when I tried to divide by 0, it was undefined. However, if I look at the top rule, this is one of the special cases. 1 over x is the same thing as x raised to the negative first power. If you try to use your regular integral rules, it seems undefined. However, it does actually equal the natural log of the absolute value of x. So if I go back to that example, my x to the negative first equaled the natural log of the absolute value of x, but I still had the constant, or the coefficient of 4 in front. So we're going to apply these rules to just a couple examples to see how they work. In my first example, I have the value of e. There's a special way or a special rule for doing that. And that was the one that says if I integrate e to the kx, that should equal e to the kx over k. In my first example, my k is actually the number 4. That's what k would be. So if I'm integrating this, I would still have e to the kx, or in this case, to the 4x. I need to divide it by the number 4, and I have a coefficient out front of negative 7, so I can just show that as negative 7 over 4. Since I'm integrating, I need to also include plus c. There could be a constant that was there to begin with before it was derived. In the second example, it's a trig function. We're integrating the cosine of x. My k for this example is actually the coefficient of 1, so it's the value 1. According to our special rules, it should equal the sine of kx, so that's just 1x, divided by k. In this case, I'm just dividing by the number 1. So I can just write that as sine of x. And I have to include my plus c. We're going to look at this trig function. I have a coefficient in front of sine. I also have a coefficient in front of my x. Now my formula says when I integrate this, it has this form to it. My 4 is my k. So when I integrate this, it becomes a negative. I'm going to divide by the number 4, but I have a coefficient of 8. So I want to do 8 divided by 4, followed by my cosine, and my angle doesn't change. That's going to remain as 4x plus c. So here's what my integration would be. Be careful not to show it as this. Even though it says the derivative of sine is negative cosine, that's assuming we have a coefficient of 1. If we write it in a form that I just did, now it looks like a subtraction. Number 8, subtract off the cosine. It's a completely different meaning, and it's an incorrect meaning. Okay, my next example. Here I have e in it. So if I integrate that, I would still have e to the 4x, and then my formula says divide by 4. There's a coefficient of 1 in front, so I'm going to show that as 1/4. My next term, if I were to rewrite this, this means 6x to the negative first. I won't be able to do that using our regular rules because it would be undefined. That's one of our special cases. So I still have my coefficient of 6. X to the negative first integrated is the natural log of the absolute value of x. And last, I have a trig function. So if we use our formula, it states when I integrate this, it's going to be negative cotangent x. Since I already have a -1 coefficient in front, a negative times a negative, that's going to become positive, and then cotangent x, followed by my plus c. Okay, my last example. There's 3 terms that I need to integrate. My first term is an x to the negative first. It's not e raised to anything, and it's not a trig function. So it doesn't mean you're always using these special rules. So I'm going to integrate that as we should. So I need to add 1 onto that exponent. And then I need to take my 3 divided by that -1. My second term is a trig function, so this one's a special case. I would have cosine of my 2x. I need to divide it by 2, so I'm going to show that as 1/2 cosine 2x. And then in my last term, we have e. The k in this case is represented with the 1/2. I need to divide by that 1/2. Dividing by 1/2 is the same as multiplying by 2/1. And last, I need my plus c. And that's how you use those special cases.